So today we are going to graph the tangent curve and see how it looks compared to the sine and cosine curve. So firstly, we normally would plot the points from 0, 90, 180, 270, and 360, but I'm going to just start with 0, 90, and 180 for now to get a feel for how this graph is going to look. So this will be 0 degrees, or 0 pi. This will be 90 degrees, or pi over 2. Then we would have 270, which is, well, wait, that's 90 degrees. So then we'd have 180, which is pi. We'll go to 270, which is 3 pi over 2. And then we will go to 2 pi, or 360 degrees. All right, that's the plan. Let's see what happens. So the tangent of 0 degrees can be found by looking at this coordinate, which is the point 1, 0. And don't forget that that is cosine sine. That is our angle. And the tangent is equal to the sine over the cosine. So the tan of 0 should be equal to 0 over 1, or 0. So that's our first point. So the tangent of 0 is 0. We'll plot a point really big right here. Really big. Next, we're going to do 90 degrees. So 90 degrees, if we were to draw our angle up here, we get the point 0, 1. So the tangent of 90 is equal to the sine of 90, which is 1 over 0, or undefined. So undefined. Alrighty, that's not going so well. So for undefined, I will be drawing an asymptote, and we will get into why shortly. For pi degrees, we come over here to, let's use a different color. For pi degrees, or for pi radians, or 90 or 180 degrees, we get the point -1, 0, which means the tan of 180 is equal to 0 over 1, or -1, which is 0. So that means at 180 degrees we go back to 0. So far this graph is looking very weird. Let's take a look. So this will be 0 again. Let's use green this time. And we'll do 270. And this point is 0, -1, which means the tangent of 270 will be equal to -1 over 0, or once again undefined. So it appears to be undefined whenever we go to either 90 or 270, and 0 for any value that's so any value that's coterminal to 90 or 270 will be undefined, and any value that is coterminal to 0 or 180 will be 0. So next we will go back to 360, which will be 0. If we went to -90, which would be on this side, we would be undefined. Because that would be going this direction. So we don't only have points that work and don't work, we don't have a lot of points in the middle. So this is one of those graphs where we actually have to take a look at a lot of the other measurements in the middle. So we're going to look at we'll look at 45 degrees for now. So if we were to do 45 degrees, we actually get radical 2 over 2. So this is for 45 degrees, or pi over 4. Radical 2 over radical 2. So if we were to do this divided by itself, we'd get 1. So for 45 degrees, or pi over 4, we actually get the value 1. And if we were to go to -45 degrees, we would get the coordinate radical 2 over 2, comma, negative radical 2 over 2. which if we were to divide those, we get -1. So for negative pi over 4, we actually get -1. And we can actually graph this now. It starts to look like this. So this curve will begin at -infinity at negative pi over 2, go up through -1 at -45 degrees. So here, let me use my pointer. So yeah, we're going to start at -infinity at -90 degrees. And then as we progress to -45 degrees, we go to 1, or -1. Then as we approach 0, we will reach 0. Then as we approach 45 degrees, we will start to go to 1. And then as we increase past 45 degrees to 90 degrees, we're going to approach infinity. So this graph will then repeat. So what will happen after that, because pretty much we've restricted ourselves, we've restricted ourselves to this section of the graph. So from -90 to 90, we go from -infinity to infinity. Now, if you weren't clear, when we use the formula sine over cosine, that's really looking at the y value over the x value, which is just another way of saying the slope of these lines. So if we look at these lines carefully, as we go from the bottom of this, it gets very close to -infinity and slowly increases to 0 as we rotate around the circle. And then we continue to rotate until we approach a slope of infinity, which occurs as we reach 90 degrees. So that's why this graph works this way. Now, if we were to then continue into 91 degrees, we would get another negative slope. So a negative slope, and it would get closer and closer to 0 as we approach 180 degrees, passing through 1 again. And then it would begin to get closer and closer to positive infinity as we get closer and closer to 270 degrees. So a tangent curve is this curve. So I'm just going to highlight it in red. So it starts at -infinity at negative pi over 2, passes through 1 at -45 degrees. I'm going to refer to them to degrees. So it starts at -infinity at the asymptote of -90. At -45, it becomes -1. At 0, it becomes 0. At 45, it becomes 1, and it approaches infinity as it reaches pi over 2. And this graph repeats over and over again. So this is technically one period of the tangent curve. So one period of the tangent curve happens from negative pi over 2 to pi over 2, and then repeats because of the way the slope of the terminal ray of the reference angle continues to rotate around. All right, if we were to fill in our table for something like 30 degrees, this would also make sense. So for tangent of 30 degrees, according to our table, would be radical 3 over 3. And for 45 would be 1. And then this would be radical 3. So radical 3 is something like 1.7. This is a third of 1.7. So these kind of indicate these points in between and kind of shows the progress of the graph as it continues. But the important parts of this is that the tangent curve has a smaller period than the sine and cosine curve. So if we were to graph the sine curve at 1 would start at, let me use a different color, let's use purple. The sine curve would start at 0, and then at 90 degrees it would reach 1, and then 180 degrees it would return down to 0. Then it would go to -1 at 270 degrees and return to 0 at 360 degrees. So this has a longer period. So this period takes a full 360 degrees, whereas the distance between negative pi over 2 and pi over 2 is actually only 180 degrees. So this is a period of only 180 degrees long, whereas a sine curve actually has a period that's twice as long. Also, the tangent curve has asymptotes. If we were to graph the cosine curve, that would start at 1, go to 90 degrees and reach 0. Then it would go to 180 degrees and reach -1. And then it would go to 270 degrees and return to 0. And then at 2 pi, it would return to 1. So that also has a period of 2 pi. So both of these graphs have a period of 0 to 2 pi degrees, or 360 degrees, or 202. It has a period of 2 pi, whereas the tangent curve only has a period of pi. So important notes is that the equation for y equals a tan of b x minus c plus d, all these values are similar, but we have a couple of things we need to note that are different. Firstly, a is the vertical stretch, not an amplitude, because it does not have a maximum or a minimum, because as we approach the asymptotes, we either approach infinity or negative infinity. So there's really no value that changes with a other than the values at 45 degrees and negative 45 degrees. If you made a 3, then it would be at 3 at those values. So looking to the sketch to my left here, if we did 3, then that would be 3 and negative 3. Or in this case, that would be negative 3, because the graph is also reflected across the x-axis. The b value is the frequency, which is how many times a curve fits between negative pi over 2 and pi over 2. In other words, between negative 90 and 90 degrees. So how many full graphs can be done in that 180 degree period. The d value is still the midline. The c value is still the horizontal shift. We don't talk about the horizontal shift that often, but it will be in some of the problems later on. The period is now pi, so not 2 pi as it was before, which changes the formulas for the frequency and the formula for the period. Instead of being 2 pi over p or 2 pi over b, depending on the formula you're using, because the period is now pi, the formulas will change to have pi instead of 2 pi. So let's take a look at some of these examples. First, we're asked for which value is x not defined for. You should be able to answer that yourself by looking at the graph. You'll also notice that this has several x-intercepts, so you should be able to answer this question as well. So it says between the values of 0 and 4 pi, what are the x-intercepts? So you can look at the graph up here as well. This would be, remember where pi is. Pi is over here. So we can see our x-intercepts occurring multiple times, and this is going to repeat as you go to 2 pi and 3 pi and 4 pi. You can make your own sketch to answer those questions. Let's take a look at the questions on the back. Next, we're asked what happens as the tangent graph of y equals 2 tangent of x increases from 0 to pi over 2. So in other words, if you were to look at the graph for tangent, remember, we start at, well, we didn't shift the graph at all, so this is just the not really amplitude changing, it just means the vertical stretch of this graph is 2. So it's still going to start at negative infinity, it's going to go up to infinity. This is from negative pi over 2 to pi over 2. And instead of these being 1 for 45 and negative 45, they're at negative 2 and 2. So the question is, what will the graph do from 0 to 2 to pi over 2? So if we look from 0 to pi over 2, we should be able to see what happens to the graph. All right, now I wanted to go over one of the sketches with you. Oh no, my graph seems to be missing. I'll have to add those to the assignment sheet, but I'll go over 2 of the problems using the 2 graphs that are on here. So firstly, we will do number 7 together, and we will do number 10 together. All right, so firstly, I'm going to do these on the graphs that are available. So this one will be graph 7, just because I could see it while we're doing it. This graph has a midline at 2, so we're going to start with a regular graph, and then we're going to shift it. So the frequency is 4. So that means normally the graph would occur one time between pi over 2 and pi. So I'm going to, but it's going to do it 4 times instead here. So I'm going to put pi over 2 here, negative pi over 2 here, and I'm going to put pi over 2 here. Now we have a negative value. That means instead of starting at the negative infinity, it's going to start at infinity. And we're going to complete this graph 4 times. So I'm actually going to just compress this graph by a factor of 4. So the first asymptote will actually occur here. Whoops. So a fourth of the way. And then that will continue over and over again. So these are going to be multiple asymptotes. So the first graph will occur, we know the frequency, so we can find the period. So the period is going to be pi over 4. So every pi over 4, it will complete, every pi over 4 radians, or every 22.5 degrees, it will complete an entire cycle. So we're going to complete a graph starting at positive infinity, going through 0 down to infinity. And we're just going to repeat that graph several times. Now this graph is going to start at negative infinity and approach 0. The last graph would have started at